Stan Gibilisco here to describe for you weak signal amplifier design, a generic weak signal amplifier design using both a bipolar and a field effect transistor. Both of these circuits can be found in my book, Teach Yourself Electricity and Electronics, 5th edition, a link to which I will provide in the description of this video, which will allow you to go to Amazon.com, browse through the book a little bit, and, if you are so predisposed, purchase it, or at least get a used copy. But please don't pirate it. I say that every time, but you don't want me to starve to death, do you? Then you will see no more books from me, nor any more videos like this. Pity. But here is the real gist of this video. A basic weak signal amplifier design. It is a Class A amplifier using an NPN bipolar transistor. The signal enters here. Microphone, antenna, anything where the voltage, peak-to-peak voltage is very, very low, so it's a weak signal, like you might use in a radio receiver or a microphone amplifier, for that matter, a sensitive sound meter. This capacitor, C2, is a blocking capacitor that keeps the bias on the transistor here from interfering with whatever the input device might happen to be, particularly a microphone. They don't like to see direct current applied to them. It reduces their sensitivity. So you have a blocking capacitor here. These two resistors, R2 and R3, provide the Class A bias for this NPN bipolar transistor. And these values must be determined by experiment depending on the particular characteristics of this transistor and also on the impedance of the microphone that you happen to be using. Some additional bias is provided at the emitter by resistor R1 to elevate it slightly above ground for DC, while C1, a bypass capacitor, keeps the signal at ground so that while the transistor can be biased for DC, as far as the signal is concerned, it's shorted directly to ground. Resistor R4 provides a certain amount of current limitation for the positive 12 volts power supply. This is the same connection as this one. They're just shown as two different terminals. And this resistor also keeps the output signal from being short-circuited to ground, which it would be if a direct line were run from the collector of the transistor to the positive 12 volts. C3 is a blocking capacitor, which again prevents this bias voltage from affecting whatever happens to be at the output. Probably another amplifier stage, such as well, in the case of an audio amplifier, something that will boost the signal to a significant amount of power to drive a headset or even a pair of speakers. The equivalent field effect transistor circuit is shown here. That was figure 24-1 in the book Teach Yourself Electricity and Electronics, 5th edition, by the way. And this is figure 24-2, the N-channel JFET equivalent of this bipolar transistor circuit here. It's essentially the same circuit, except there's only one resistor necessary to bias the control electrode, the gate of the transistor in this case. Otherwise, the circuit is essentially identical to this one. The advantage of a field effect transistor over a bipolar transistor is that the high impedance of the field effect transistor keeps it from drawing a significant amount of current and therefore makes it possible to have a much more sensitive amplifier than you would normally be able to do with a bipolar transistor such as that. I am an amateur radio operator, by the way, in case any of you were interested. Call sign W1GV, Whiskey 1 Good Vibrations. I'm mainly a CW operator on 14 and 21 megahertz and also on 18 megahertz. But you won't find me on the air much these days. There's too much human-made noise at my QTH. But again, all of this and more can be found in my book, Teach Yourself Electricity and Electronics, 5th edition, available from Amazon.com, and I'll provide a link to that page directly in the description of this video. Hope that made things a little clearer for you if you weren't sure exactly how to design or how the basic generic design for weak signal amplifiers. Stan Gibilisco signing off, saying 73 in ham radio jargon, which means best regards for those of you who don't know it. So long for now.